Okay, this is exponent rules. We will start with two rules that are in our book that you can refer back to. But for now, I'm going to use things that I used to teach it prior. What that means is that the material that you're looking at now is similar but may not have the exact same word uses and choices, but your book explains the same sorts of things. So the first thing that we want to review is that we can combine terms that are alike. And we've talked about that a little bit in class. What you want to make sure is that you do not change the common value. So these, because they both have a x squared and they both have just a y with one, the imaginary one that's not there, I can put those together. So this would be -1 because 9 minus 10 is -1. X squared y. You have to keep the variables on there, but you can only put them together. This one, I'm putting 6w, 8w. I'm going to rewrite it as it says. So subtract 6w from 8w. That means 8w minus 6w. Well, that means I have 2 w's left. Now this one down here, I have to look and see what are my like terms. So I see an x squared and an x squared. But then this one is x squared y and x squared y. So I'm going to be smart and rewrite this with the terms together, making sure that the sign that's in front of it stays with the variable with its coefficient. Okay, so, and then minus 9x squared y minus 11x squared y. Now, if you remember all those things that we taught when we're dealing with adding positives and negatives. In this situation, I have 2 positives, so that becomes 14. Keep the variable with it. But that this one, I have a -9 and a -11. Well, since they're the same sign, it's going to stay a negative, which is minus 20, and it keeps the variable. So those are combining like terms. That goes along with this so that we know how to practice. So at this point, I want you guys to try these on your desk and see how you do with combining like terms. I'm going to hit pause, and then we'll come back and review. Okay, so hopefully we have figured out that these two go together, 7a squared b squared, and these two go together, a +2 and a -4. So that means it'll be a negative. Oh, those don't go together. Forgive me. Notice, I almost got caught. That is a 2a squared, which is different than b squared. So I just bring that down. This one, the only terms that I can combine is the +4d and the +d. So it comes into 3c plus 5d. I can combine these two. A +2x squared and a -3x squared makes it -1x squared. I can combine these two, +4xy minus 5xy. I'll be left with -1xy. And then this lonely guy over here is a +2. So that's your final answer for those. Hopefully you got it, understood. We'll continue to do that as we go on. So these are the rules. There's a rule when you're multiplying monomials of the same base. So we combine like terms, but now we're looking that they have the same base. So the exponents would be adding. So the explanation that we give is notice that they are both a, okay? There's a shortcut, and that shortcut is to look at their exponents, and there's a rule that we're going to come up with on how to deal with them. So if we write a squared out, or a to the second power out, you get a to the second power. I do not know why we switched places, but that's the situation. So a squared becomes a times a. A to the third power becomes a times a times a. So the thing you need to think about is how many a's you see right there. Well, I see 1, 2, 3, 4, 5. Well, that would be the solution. So what you're going to notice, and it just kind of says it again, a times a times a times a times a is a to the fifth, or a to the second times a to the third is a to the fifth. So the rule that we find out is when you have those original problems, you see the 2 and the 3, if you add them, you get your solution. So an example of that is down here. Notice that we have changed these from adding. These are now multiplying. So since they're being multiplied, I can put them together. So the product rule has to do with the fact that it's a product. And product means multiply. Well, in this case, all of these that don't have a little number has a 1. So the C I can't combine with anything, so it's just regularly C to the first power. But this D has 1, 2. So I keep the original coefficient, I put the D, and I can do 1 plus 1. So the final solution will be 3C times 4D to the second. If we go to our next problem, I've still got to look for common denominator, or common terms. So these two are solo, so I'm just going to bring them down. 2a squared times 4b squared, okay? Now there's a long, complicated reason why you can't combine these a's and b's with the other a's and b's, but it boils down to the same thing. They are not like terms. Like terms have to have the same base with the same coefficient, totally exactly the same. So I can only put 4ab and 12ab and 3a squared. Let me try that again. I can only put the two yellow ones together because they have the same bases with exponents. So it's a and b. There will be more practice with this, but that's to make sense. They have to have the same base. So I'm going to start I'm going to write that out. I'm going to go ahead and multiply the 3 and the 4 because I can put those together. That's 12. And then I'm going to write A, and one of them has a 2 and the other one has a 2. And B, one of them has a 2 and the other one has a 2. So my final answer for this one will be 2a squared times 4b squared times 12 to the 4th b to the 4th. Okay? Now technically, I can go and I can put this, this, and this together. But we aren't going to worry about that at this step. Okay? Right now, we're just kind of combining what's normal. All right. The worksheet that I do give you for review is not at this level. They're pretty much more broken down and simple so that you can see them easier. All right, let's try this next one. So the 2 is by itself, but I can put this one and this one together. I usually have some sort of pattern so that I use them all. So 4b, oh, sorry, it's not 4. 2 times 3 is 6. B to the 2 plus 2 times, and I can put these together. Times, and I'm going to put the 4 and the 5. I'm going to go ahead and multiply that. That's 20. A to the first plus first, because remember there's 1 there. There's 1 there, there's 1 there, there's 1 there. And b to the first plus first. So my final answer will be 2 times 6b to the 4th times 20, a squared, b squared. This is the product rule. It means when you multiply. When you're dividing, it's the opposite. You're going to subtract the numbers. I know that there's some other examples that we can do at the bottom, but here's the reason why. So this is our big you're going to multiply, you're going to subtract the top from the bottom to figure out what it is, okay? Because when you are dealing with them, you'll notice you can cancel. That's why it works. If there's one over top of the other one, that turns into one and it can go away. So this is our generalization, our solution. Okay, if they're being divided, you subtraction. Okay, I'm going to look at these. Now notice there's a D1 and a D1, so they cancel. So 4D1 minus 1, well, that's D to the 0 power. So that equals 4. Now this one, I have to look at my common things. Okay, those two would cancel because 2 minus 2 is 0. But I'm going to go ahead and write it out. So I'm still going to be stuck with 1/2. Okay, but A minus A. And then I have the B squared left. Okay, so that means 1 minus 1 is 1/2 A to the 0 power B squared. So you're left, this goes away because the 0 powers means it's not there. 1/2 B squared is your final answer. Over here, the only thing that they have in common now is I can simplify 2 over 12. So 1/6 x to the 5th. This could also be written as 1x to the 5th over 6. And this one could have been left as 1b squared over 2. But it's the same thing because it's still division. Now again, the ones that you're practicing don't have this many variables. They're much more obvious. But I want to show you the more difficult ones in order to see that that's where we're leading to in some pieces. But right now we're going to practice the basics. We're stopping right here because we have learned the two rules that you use for exponents when multiplying and dividing with the same base. There's a worksheet if you are at home. You should be able to click on this and you will see the same picture. So that's where we're stopping.